So let's start off with what you need to know first. First of all, this is the JGMaker Artist D 3D printer, and the first thing you need to know about this 3D printer is that it is a Kickstarter 3D printer. Now, what does that mean to you? Well, it means that this is beta hardware. They have sent out beta units of this printer to reviewers such as myself to give you guys a look at exactly what they will be getting, or hopefully close to what they'll be getting if they back this project. Now, will what you receive be exactly what I have here today? No, it won't be exactly the same, and I already know that because they've already agreed to a couple of upgrades over what you see here. But all I can do is give you my impression of this printer. Now, I have already gone through the paces with this printer just as I would any other printer that arrived in my shop. And let's just say that that didn't go to plan. I have had a couple of issues with this printer that have actually made me have to stop testing it. So I'm going to do this a little bit different. Rather than give you all that footage that I've given you, and honestly you can find some of that footage from other YouTubers that will show you the construction of the printer, that will give you a detailed rundown of all of the features. But I want to do is give you something a little bit different given the things that I have found with this printer. I'm going to cover the construction of this printer. How well is it built? How is it put together? Is it really up to my standards in terms of build quality? I'm going to cover the electronics of the printer, which is going to show you the inside of the printer. Are the electronics the latest and greatest? Were they assembled correctly? Am I happy with what is found inside the printer? And then last of all, I'm going to talk about the extruders that are in this printer, because they're a little bit different than what you probably have seen in a lot of the mainstream printers out there. And honestly, that's where this video is going to end, and I'm going to show you why right here on Kersey Fabrications. Let's go. Hey, this is Editor Chris here from the future, and I'm about to render this video down for release. But before I did, I wanted to include kind of a secondary introduction here because I know this is a long video, and I appreciate you even clicking on it and making it this far. But there's a lot of good information here about this printer and about the testing process in general, and I really didn't want to cut any of it out. But I do care about your time and I do care about your interest. So if you look down in the description below, you're going to find a table of contents for this video, a chapter listing that will allow you to jump to the portions of the video that you find most interesting. So feel free to jump ahead, jump around, jump to the end, whatever you want to make this the most useful video for your needs. Now, obviously, you watch it all the way through, you'll get all the content, you'll know everything I know about this printer, and hopefully that's what you came here looking for. But anyway, I also wanted to say, if you're looking for any links, the Kickstarter link for this printer, if you're looking for various links to things I may have talked about in the video, please check the description below. You're going to find everything you need there. And if I missed any links and you need more, please leave me a comment, let me know, and I will be sure to add that to the description. And without further ado, let's get going with this review. Okay, as you can see here, I've kind of left a mess on this table because this is honestly how I left the printer at the very end of my testing. So let me go over the features of this printer, and I'll put some up here on the screen so that you can kind of follow along with me. So first of all, as you'll notice with this printer, it's got a pretty good build volume. The build volume on this printer is 310 by 310 by 350, which is one of the reasons I decided to review it, because it's larger than average. The normal 3D printer you're buying these days is going to be that 220 variety that's going to be a little bit smaller than this. This is a good medium-sized build volume that doesn't take up too much room, but yet gives you a little bit more space to possibly print a smaller helmet than what you're going to be able to fit on the 235, 220 bases that I was talking about. Now, what makes this printer really special, of course, is that if you can see here, it has two independent extruders. It's called an IDEX printer, independent dual extruder system. And it means that it has two separate extruders, one on the left, one on the right, that allows you to extrude two different colors, or print soluble support, something like that, out of one of them without having to do nozzle swapping or anything fancy like that. It allows you to do fancy things like print 2 copies of the same model at the same time, as long as it fits on half of the build plate, or print 2 mirrored images of the same model at the same time, which would be really nice. For example, if you had the left and the right side of a part, maybe you're building some sort of case that has a clamshell effect or something like that, this printer would allow you to do that, and that's really the draw of this printer. Now, as I mentioned, they are dual extruders, and both of these extruders are direct drive, which I know a ton of people love direct drive extruders, and that's built right in here. It has a 32-bit silent board. It has dual Z screws, both of them on their own motor. Now, both of those motors, as I'm going to show you here in a few minutes, both of those motors are being driven off the same stepper, but that's not really a problem. I've seen that plenty of times. They claimed in the instructions that it's like a 5-minute assembly install. That's not true. Honestly, if I was working at a decent pace and kind of knew what I was doing with it, it's probably more of a 20 to 30 minute build, particularly when you start taking into account some of the setup that you're going to have to do once you've actually finished the assembly process. The speed they're claiming on here is 10 to 150 millimeters per second. That's probably fairly accurate, although 150 millimeters per second, I would actually have to test that to be able to verify that, and I didn't really get that far. Now, the nozzle is PTFE line, what that means is there's a small tube of plastic that goes all the way down to the hot end. That's going to limit you to 245 degrees Celsius, which means no high temperature filament on this printer. But depending on what you're printing, that may not be a problem. Now, one cool thing while we're talking about the nozzles and how hot they heat up here, one of the cool features of this printer is that it's got this great hot swap sort of nozzle feature where you press a button, drop a nozzle out, put a new nozzle in. That's a really nice feature. I hope that can be used also to clear clogs, but I guess that really depends on what kind of clog you have. As to whether that's super useful, that actually is going to depend a lot on JGMaker, because if this is a proprietary nozzle system, they're going to have to release new nozzles to make that actually really useful. You're going to need different size nozzles, different material nozzles so that you can print abrasive filament, that sort of thing. Otherwise, I don't know what this hot swap sort of feature is going to really buy you if there aren't any other nozzle options. It does have a hot bed on it. The heated bed will go up to 90 degrees C. Again, you're not trying to print super hot filaments on here. The high temperature filaments, it's not enclosed, so you're not going to be even printing ABS to a great extent on this printer. The bed has manual leveling on it, meaning you don't have a BL Touch or anything like that. That's going to help you do the bed leveling. We'll get a little bit more into that in the construction, because the bed leveling on this printer has some issues. It has dual filament runout sensors. As you can see here on the top of the printer, we've got filament runout on both the left and the right side. Found, at least for me, these runout sensors, they do the job, they work. The drag on them is a little bit more than I'd want them to be, because I just feel like you have to pull a little bit on it. It's not as smooth as you would want, which is weird because I took them apart. It actually does have a little wheel in it, and so not really sure why there's so much drag on it. And well, the wiring on here doesn't really, this one works fine, wiring on here doesn't, so they don't really allow them to move as much as you'd want either. You'd want these to go side to side easily. On this side, I'd actually have to do a little bit of rewiring to get that to work correctly. For the dual independent extruders, they have these nice brushes on each of the nozzles, which are really nice for when you park your nozzles. It's going to extrude filament. It could have a little bit of ooze out of that nozzle while it's sitting over here, and that brush is there to clean that nozzle off. That's a really nice feature, because again, it's one thing that's going to make your prints look that much nicer. Let's go ahead and talk about cost while we're in this section. So I don't know where we are on the Kickstarter as you're watching this, or even as I release it. So let me go and cover the full gambit of Kickstarter options you have here. First of all, the lowest price available for this printer is $339. They call that their flash sale price. And at that price, if everything works as they say it will, it's a steal, because this is a lot of printer for $339. It's a large print bed. It's a large just print volume overall. Has a lot of features that you will never find in that price range. But again, watch the whole video and make up your own determination if this is something you want to spend your money on. Next price up from there is $389, which is their super early bird. Again, that's a terrific price. Anything, honestly, for this level of printer, anything under the $500 mark, I think is pretty good. $450 or so is going to be actually a really good price for this printer. Early bird is still under that at $429. Kickstarter special is $469. And then the MSRP they're claiming on this printer is going to be at the $599 mark. So I think the MSRP on this is a little high, not too bad. But all the Kickstarter prices are well worth it if you get everything that they claim that this printer can do and they deliver on their promises. So I guess now it's time to get into the details of this printer. I'm not really, again, going to go over the details of the assembly and everything like that. Again, I don't mind including some links to some other YouTubers that have done that level of detail on this printer, but I want to cover some other things in my video to try to keep this at a manageable length, and the things I need to cover are pretty important. So let's go on to the construction of this printer. So since we're going to talk about construction, I guess I will mention a few things about the build process. Number one, everything did go together well. I really didn't have any huge issues. The instructions that came with the printer are overall well written, and everything goes together as the instructions say. I love a few things about their instructions. In fact, all of these wonderful ribbon cables are well labeled on here. They all have numbers on them, and so you can actually see 6 goes to 6, 4 goes to 4. It's really easy to assemble and wire up correctly. The only real issues I had was that when it came time to put the end stop and the filament runout sensors plugged into the bottom, is that was not in the instruction manual, and it was definitely not intuitive. So the plugs are black and white, and the sockets are black and white, and for whatever reason, those go in the opposite way. So the white plug went into the black socket and the black socket went into the white plug. It was easy to figure out because when I went to home the printer, when it hit the Z, it didn't stop. So that one was pretty easy to figure out. I swapped those around and everything went to plan. The only other thing I really ran into was that the white buckets here on the side, they've got a lot of adjustment to them, and they don't really need that because there's only one place you can install those white buckets to where they won't run into these things at the bottom, these metal pieces where you do your plugs. They run into that if they're not exactly in the right space. So I probably would change those buckets to where you can only screw it in one place and then save me some headache, because I did have the problem where it was hitting these before it was homing correctly. So about the construction of the printer, overall, the printer is built very well. There's not any flex in this printer. The base is very well built. Lots of screws in it so that it holds tight. It doesn't have any bowing or flex to it. They do have little notches already routed out for you so that when you go to attach the gantry, you have a place to set those. I didn't feel like those were routed the best because there was a little bit of slop, but once I had everything tightened down there, again, no more wiggle, so I can't really complain too much about the assembled unit. Now, as you can see here, something I didn't mention earlier was it does have a linear rail on the X-axis, which is a really nice thing to have, particularly on one of these IDEX systems, because you're going to want both of these X gantries to move together on the same plane. And so what that does, this keeps the X and the Y right there next to each other, and it just gives you an overall really smooth movement on that X gantry, which, if they're right about their maximum speed, is where you're getting some of that speed from, because this is a very fluid motion system. So, as I mentioned earlier, it does have dual Z screws, which is a really nice thing because it keeps your X gantries level. So there's 2 motors, 2 screws, and again, as I mentioned, both of those are connected actually to the same stepper driver, which we're going to take a look at in a minute. And that keeps those 2 moving together. Now, one thing that they did, and I keep seeing this on a lot of printers and I don't really understand it, is there is a belt system at the top of this printer that makes sure that both of those are staying in sync with one another so that they don't get out of step a little bit. Now, while it sounds like a terrific idea, I personally have never seen the 2 steppers get out of sync in such a way that you would want the belt to try to correct that. First of all, by doing the belt system, you could be transferring the load of one of those steppers over to the other stepper if it tries to miss a step, which actually could throw off the entire gantry rather than maybe just a partial step on one side. Also, if you have your electronics configured correctly, I don't think you're going to have any missteps or any slippage there. If so, you've got kind of a bigger issue. So while I see this a lot, while it seems like a nice feature to have, I don't still see really what the point is to doing that. One final thing, this could be really in the electronics or the construction setting. Let's talk about these ribbon cables that they have connecting everything. Well, I've seen this on some other printers, and various people have complained about whether they're going to wear out or whether these are a good idea over just traditional wiring. And honestly, I don't know exactly what these are made out of or exactly what classification these fall under, but I am overall happy with these wires. They don't seem like they're the type that are going to wear out quickly over time. They are of a rubbery kind of material. It's not very plasticky. It feels very pliable, so I think it's designed to move over time. The connectors, as long as those are stable, you're probably going to have a long life out of these. But I don't want to harp on it too much because I just know that there would be some questions, so I really wanted to comment on it. I'm overall really happy with these. I don't think that these are going to present a problem. So next up, we've covered construction. Let's talk about the electronics of this printer. So I'm going to flip this thing over and walk you through what I found inside when I turned it over. So here we are at the underside of the chassis. So I wanted to take a look at this level first because there are a couple important features that you'll see under here. Number one, they've got this cutout for the Y stepper motor that's going to help keep it cool. This is a nice addition so that this particular stepper is not going to get too hot. What we have right here and here is where we attach our upright, our Z axis to this so that we have a good solid connection. We have 2 screws in each of these that go directly into those extrusions. Now, looking at the cutouts here, this one is my biggest concern because this right here shows that we are actually blocking the airflow for that power supply. So this really concerns me that the power supply could potentially overheat because we're blocking the majority of that fan. The better way to have done this would have been this whole area could actually still be filled in, and what they'd want is just a circle here so that that fan can do what it's supposed to. So this needs to be fixed, I believe, before they ship this printer. Down here, this cutout is directly over our main board, which is perfect because it's going to provide extra airflow, extra circulation for that main board to keep any of our steppers or our main processor from overheating. Over here, we have an opening that they've given you for these plugs possibly. I think it's actually a better handle to actually pull open the case. Maybe that's what it was for, because I don't know why you would need access to these unless they're worried about these coming off during shipping and want you to be able to easily reattach those, because these shouldn't come undone. Now right here, that doesn't go anywhere, so I don't know what the purpose of that hole is. And the only thing left down here are your feet, which once you have everything assembled, provide a very stable foundation for this printer because there are 12 screws all the way around here, making this a very solid assembly. So let's crack this open, see what's on the inside. So here we are with the chassis cover off, and as you can see, we've got a very well organized interior to this chassis, one that I'm actually really happy with. As you can see that they've taken extra care to make sure that this is wired cleanly and that nothing is going to get caught or come loose during the shipping process. As you can see, they've wire loomed almost every wire in here. They've done a really good job of covering all of our bare connections, as you can see here. And down here, they've even put ferrules on some of these wires, some of the higher current wires that are going into our main board, which is terrific to see as a protection for the printer and for the user, that these will not have any arcing issues. Right here you can see that they've actually added cooling for the main board, which is absolutely terrific because now we have direct airflow. This is a blower fan, and this is going to give us direct airflow over the cooling of these stepper drivers right here. Now, one thing that people have complained about, and they're right, is that this is a rather loud printer because we actually do have another fan here. We've got the fan on our power supply. We have this blower fan, which is going to be kind of loud, but you're not going to have to worry about overheating on here. But people did not like the noise level that they've heard on this printer. I'm not so sensitive to the fan noise as I am to the stepper noise, so it didn't really bother me. But they have said that they are going to address the fan noise issues I'm hoping that they can do with some sort of control on the motherboard. The power supply is a 500 watt Chang-Lang power supply. This is actually the same power supply that comes in the Ender 5 Plus unit, but this is a much smaller printer in terms of just the size of the plate. And so you're not going to need as much power to drive this printer. I actually do believe that this power supply does have enough power to drive what you see here, as opposed to the Ender 5 Plus, which is where this was actually under spec for that printer. Now, I think everyone would love to see a higher end power supply in here, something from Meanwell, something from another name in power supplies that have a little bit more technology in the supply to keep it from overheating, that keep it from burning up in case it does overpower, but I do think that this will be sufficient for this printer. As you can see here, we have a standard 12894, I think that's right, 12894 controller here, which is our LCD controller. Again, I personally love the stock Marlin LCDs because it gives you more control over the printer than any other touchscreen that I've seen before, at least that I've personally tested. But a lot of people like the touchscreen. It's more user-friendly. I guess more is at the touch of a button, as it were. But I really like this display. It works, it does the job, and that's what they're using right now. I have heard from them and from others that they are going to go with a touch display by the time that they ship. Now, whether that will be better than this is completely up to them, because they're going to have to figure out what's going to be their best option. Now I want to zoom in on the controller so that we can talk about what they've done here. So here we are with the close-up of our main board, and as you can see right here, this is an off-the-shelf MakerBase MKS Robin Pro version 1.0, and what this is a low-cost, feature-rich, open-source board. And this means that I was easily able to find the source code I needed when I wanted to recompile some of the source for this printer, which I'm going to be getting to later. This is running a 32-bit chip, ST Micro 32, which is running at 72 megahertz. So this is actually a really speedy main board for what you're getting, and it also has plenty of flash space on that chip. Now, as you can see, it's got a full-size SD card. It actually also supports their own Wi-Fi adapter, which will go right here. As far as the electrical connections, everything, again, very well wired. All of the connections are well assembled, well put together. They even have the ferrules, like I mentioned, over here for the main power that's going into the board. And as we can see here, they have populated all 6 of the stepper driver locations. And I'm going to go through real quick what they've got here. So what's kind of odd is that they've chosen 4 4988s, which are the green chips, and they've chosen 2 2208s, which are these white chips with the blue heat sinks. And what's kind of odd about this, number one, the 4988s are old chips, and while they are fine to use on things like your extruder, they're not particularly great these days for things like axes. And they've used them for both of their X axes, because what we've got here, this is your first X, this is your Y, this is your Z, and again, both Z motors are running off the same axis. Right here we have the first extruder, the second extruder, and this then is most likely here, this is going to be your second X driver. So it means that both your Y and Z, they're trying to make quieter and run smoother, but they haven't done the same things for the X, which is just very strange to me. Also, when looking at the firmware, I noticed that they put these in standalone mode, which also doesn't make any sense. Why they didn't use the UART on board to potentially control these directly. Now, I don't know for sure if the UART is fully working on this board, but at this stage of the game, I definitely think you need to get that working. You need to have these UART based so that people can adjust the current easily, as well as turn off and on the silent step mode in case they want to go faster. And again, if you're going to have it on 2 of your axes, go ahead and put it on your 3rd axis. Populate both of these with 2208s also. Again, whether you keep these on the extruder, that's fine with me. You need a little bit more oomph on the extruder, and I find 4988s are great for that. Now, just to be thorough and complete, you could populate all 6 of them with the same driver, give someone full control in the firmware. That's not what they've chosen to do here. But I don't know a lot about this board other than what I found out from this review, other than what I found out when I was actually programming this myself with Marlin. It looks like a good board as long as it holds up, you know, to extended use on this printer, which, you know, it's going to have a lot of movement. It's going to be using all these steppers pretty much simultaneously. So I like this choice. I like that it's a powerful processor and an open source board. They just need to, I think, change out some of their stepper options here. But other than that, this is the inside of the chassis. Let's go back to the bench. Now I have just one more technical thing I would like to cover on this printer, and that's the extruders. But first, let's take a look at my test prints, and that will lead into the extruder discussion. So first of all, on my SD card, it did not come with any pre-sliced G-code, so I had to slice one of the models that was already there. And the model that I found for just simple single extrusion mode was this little cat, a little waving cat. And overall, this print turned out pretty well. Now, I didn't expect a whole lot because the printer had not been calibrated, and in fact, one of the things that you have to do with this printer is set up your own profile inside of Cura, because it does not come with any Cura profiles. In fact, it basically walks you through how to set up your own profile in the manual, which is fine because then you have something that you can use to print with, but there's no tweaks, there's no tuning. Basically, from that moment on, you're going to be working to find out the tweaks and the tuning yourself. So back to the cat. When I saw a few issues with the cat, I didn't think much of it. I mean, after all, it's the stock Cura profile for a generic printer, so I couldn't expect too much. But I did see that there were some missed or at least inaccurate extrusions that I found on the back of this cat. The front of the cat looked fine, but on the back, anywhere that it had to retract and start again, up near the top of the head, I did see that there were some slightly missed lines, and this may come back into play in just a minute. Now, next thing I want to do, of course, is try out some of this great dual extrusion feature that we have on here. And I found out very quickly that the dual extrusion on here is not calibrated out of the box. And what that meant for me was I had to go find my own calibration models myself. I had to go find my own calibration tools myself and do this manually. Now, it's the standard Marlin calibration. You go in there and you set your second extruder relative to your first extruder, and so there are, you know, a few millimeters off, or I guess in the X direction, it's more than a few millimeters off, but you have to go in and you have to set those yourself. After maybe an hour, I don't remember exactly how long it took, but after maybe an hour of tweaking those calibration settings, I was able to get out my first dual extrusion print. And as you know, if you've seen my other printer that has dual extrusion, I did this little frog because I go straight to this because it's about the toughest dual extrusion print I know of, due to the number of starts and stops and everything that you have to do to get this just right. Now, when I got this one off the printer, I did see that my calibration was still not perfect. It still was a little bit off because some of the lines on the frog bulged out a bit more than in other places. So I think there was a little bit more tweaking I could do here. The other complaint I had, though, it wasn't particularly smooth. And some of that's from the miscalibration. Some of it just feels like I just didn't have the cleanest calibration here. And again, I think some of this has to do with the fact that there's no profile for this printer, and that now I'm going to have to take the time to figure out what is the correct retraction for this printer, and all those other little tweaks that you can do inside the slicer. They really need to, before they ship this printer, come up with a Cura profile that works best for the various modes, so that when you have to do something like this, you at least get the best results possible. Now, I was happy with this frog. The frog turned out just fine. It finished it. It didn't come off the plate, but just as a side note while I'm talking about it, nothing comes off this plate. While you definitely don't want a plate that is going to leave you with prints coming off, this one does the exact opposite. And I had many times where I was scraping hard to get my prints off of here. And it's even worse if you have a failed print where that's really thin. It does not want to come off of this build surface. So I recommend that if they're going to go with what is actually a very nice steel flex sheet build plate, and I didn't mention this before, but it is a terrific build plate in terms of flexing and getting your prints off, but if it sticks too much to the plate itself, it's not even going to work. It just flexes underneath the print itself, and then the flexibleness doesn't do anything. So they need to come up with a different coating for this, or just, you know, do a PEI sheet on top of this, because it's going to be way better than what they currently have on here, because too sticky is, in my book, almost as bad as not sticky enough. The final things, of course, I wanted to try out, just in terms of the simple prints, was to try out one of the IDEX mode prints, which was a copy mode print. So I decided to go with a Megalodon Benchy, which I have done in the past, and the pink one turned out pretty well. Although I saw some similar missed extrusions or missed lines, whatever you want to call them, that I saw on the cat. Again, not thinking much of it, still hadn't done much tuning, but really the smoking gun here for me was the blue one, which is headless, or not headless, but cabinless. The top of the cabin, there was some sort of clog at some point in here that I don't know if it was caused by the extruder itself, if, again, they should have included correct retraction settings, because it is a direct drive extruder and they didn't include any shorter retraction settings that I could use here. So this failed, and I ended up with, it tried to continue, and it actually did finish the print, but obviously a failed print is one that comes off the bed in more than one piece. Now what this made me want to do, of course, was, okay, I've dealt with this long enough. I've dealt with not knowing why my print quality is good. I obviously know how to tune all of this stuff in Cura. I'd be happy to produce a good profile for them, but this is where it kind of went off the rails when I started to tune the printer itself. The first thing I ever am going to do in a new printer is tune the extruders, and I tried to do that here, and I was getting really poor results because, first of all, I acknowledge that in their firmware, they had it where you have to tune these two extruders identically. They assume that since both of them are the same parts, that the calibration should be the same. That's not true, and we really should have that built into our firmware to handle both of those tunings separately. So I went off. I spent a couple of days building my own firmware for this printer after finding out all the correct settings. There was an issue with one of the firmware settings that made it fail for a couple of days, but I did get it working. Then I went to tuning, and that's, I think, where I need to cut over to pulling apart the extruder. So this is where I really found the problem. I found out that I really couldn't get these tuned. That when I went to calibrate it, I would calibrate it, and then when I came back to see how my calibration was, it was still off, and then I'd recalibrate it and it was still off. And this was true for both extruders, that no matter what I did, the calibration was going to be off on them. Something is wrong here, whether it's the stepper motors, whether it's signaling to the stepper motors. But anyway, what I want to do, let me show you the disassembly and breakdown of those extruders, and then we'll meet back here for my final thoughts. Okay, here we are with the left extruder assembly. I'm going to pull this one apart. First of all, we'll get rid of the ribbon cable by pinching both of the sides, and that comes right out. And we'll get that out of the way for the most part. Next up, I'm going to go ahead and pull off the thumb screws. Okay, I'm going to pull off the front ones because the top ones up here are going to be the ones that are really holding it on. I'm going to remove one of them, and then when I get time to do this one, I'll be holding on to it so that it doesn't fall out the bottom on me. Okay, now this whole assembly comes out. We're ready for disassembly. Okay, so here we are with the complete extruder assembly. Let's talk about how it's kind of put together. So the top here we have just a breakout board, and what that means is all of my signals come in here through that ribbon cable, and then that breaks out into the various signals that we need in the extruder assembly. So over here we have, this is going to go to our stepper motor, which goes over here. We have two fans in here, which are these two plugs. So we have this fan and this fan. This is our part cooling fan, which goes down here to the bottom. This is our hot end fan, which goes to cool off the hot end. So the last two plugs we have here, one that goes to our heating cartridge, which is in here, and then of course the other one, which is our thermistor, which measures our hot end temperature. So let's go ahead and start pulling this apart and see what it looks like. So first of all, we can pull off the sock because it's non-functional other than to keep everything to temperature. Let's go ahead, and right here is normally what we'd push to pull out our nozzle. We can go ahead and do that while we're at it. I'm going to have to put this in just a little bit in order to do that. Now the way this nozzle works is you simply push this in and you should be able to pull the nozzle out. And there we go. Easy nozzle assembly. That should allow us to hot swap these. No, not necessarily hot swap, but swap them on the fly much easier than what we'd have to do traditionally. As you can see, there's a PTFE tube in here, and other than that, it looks pretty good. Now, again, we will need the company to provide replacements for these in different sizes and different materials, so that is a problem versus a traditional nozzle. Next up, we can start pulling this apart a little bit. We won't need, well, we'll go ahead and leave that in case we need it. And let's go ahead and start pulling this apart. First of all, I'm going to pull off this controller board on top, but we can go ahead and also, oh, we can leave these plugged in here. We'll pull them off of the various components as we need to. Pull this off. Now, there are some washers in here keeping everything separated. We're going to just let those fall to the side. Now, as you can see, what they've done here is, in order to keep this board from shorting out here on the bottom, they've included this plastic piece, which is just basically an insulator to keep anything from shorting out. Now, one thing I noticed on this is that they didn't actually remove the plastic, which would have been nice. The plastic sheet on here, just because of heat. I mean, this could have melted, and if you'll notice, mine has also shattered a bit right here, which is going to be under these connectors right here, and apparently when you tighten those down, they actually did shatter. Now, on the other side, you'll see they didn't remove the paper either. Now, I think the paper is probably what's holding this together for the most part, so as much as I'd like to peel that off, I'm not going to because this is broken, and I'd like for it to stay together to protect the electronics. Now we can go ahead and start pulling off some of this cooling here. So let's go ahead and pull off the fan. Okay, so this fan will come off of here. I can keep everything and pull those out. This is the heat sink that cools off our hot end because these go directly into here for cooling, as well as obviously if this was still in here, this would be going up into this assembly to keep it cool as well. Now let's go ahead. If we pull off these screws here, that will remove all of this from our actual extruder here. So I'm going to go ahead and remove these screws and get our parting cooler out of the way. So I think the only thing holding these on are these two screws here. Now while I've got this in my hand, let's talk about what they've done here. So they have a 3D printed part cooler shroud that sends the air from the fan down to our hot end. Now this is a pretty good design. It actually puts the air right where we need it to be. But unfortunately, this is 3D printed, and it appears to be out of PLA, both from the way it feels and because if you see right here, it does appear to already be melting some from this heat area. So this does not give me long-term confidence about this against this hot end, because this probably should be printed out of something that can handle more temperature, PETG, ABS, something like that, because this is going to be sitting near here. It doesn't have to handle the full heat, but the radiant heat coming off of there, and obviously it's not doing that. You'll notice also this hopefully is not a final part, because if you see what they've done, this actually doesn't go up into the fan. And so they've had to put a little piece of sealant, some caulk, along this line to keep the air from leaking out. So this is hopefully not a final part, because this is not really a solution to this problem when we could develop a better part to fix that issue. Let's go and take this last bit apart here. We're going to pull off the extruder from the motor. This whole thing should fall away after this. Okay. And as we say, the motor comes out there. has a single hopped gear right here, which goes into our extruder. I'll go and pull this off of here too. Okay, so now that comes off and we're left with just this assembly, which is just our, that's just our extruder. So as you can see, this is a very basic direct drive extruder design. In fact, it's not geared at all. It is just taking that hobbed gear directly off of the stepper motor and putting it against the filament. And hopefully you can see in here, there's just a smooth, I got some filament stuck in here. There's just a smooth wheel that filament gets pushed up against in here. Now, what that means is it is not geared on both sides. There's nothing other than that one side pushing that filament through. So this is one of the potential areas that we could be seeing some slippage. I don't expect it to. As long as this is good and tight, we shouldn't be getting slippage. But again, since it's not geared on both sides, since there's actually no gearing in here, we don't have any extra torque pushing on that filament. So I'm not 100% sure what the cause is. As you can see, this button here, all it does is just loosen it up just a little bit so that you can move that filament around. But it doesn't provide, you know, a lot of movement. So I don't think that that's the cause. We could be getting slippage here. We could have an underperforming extruder motor that is allowing some missteps. At this point, I'm really not sure as to what the cause is. But as you can see, this is the basic design. The filament comes in the top here, goes out the extruder at the bottom with just, again, one pass through here with that extruder motor clamping on one side. This has been a walkthrough of how this extruder works. Now we have a better understanding of what could be going wrong. We'll have to see. It would take a lot more experimentation in order to figure out what exactly is going on, switching out the motor. It's not a whole lot you can do in here. You can hold on to the filament a little bit. There's some debugging we can do, but anyway, that's what we're dealing with here. It's not a over elaborate extruder design. So what's causing our slippage and our uneven extrusion is still a mystery, but we've got some things we can track now. So now it's just a matter of putting this all back together so that we can get up and running and testing again. Okay, so let's do this for posterity. So right here I have a mark on this filament at the 100mm mark, and on this filament I also have a mark at the 100mm mark. And so what I'm going to do, I'm going to go into the firmware just on my display down here, and I'm going to go to Motion. I'm going to go to Move Axis, and we're going to do the left extruder first, and I'm going to say Extruder E1, and I'm going to go to Move 10mm, and now I'm going to tell it to move 100mm, and it starts to move. And what we'd expect if it was properly calibrated is that this mark right here, which hopefully you can see all right, will be exactly at the tip of here, because that's where I measured from. I took my ruler, I measured just like this up to the 10cm mark. So that's what we're going for. It should extrude exactly that amount. And I have calibrated this once to make sure that I should be getting pretty close to perfect extrusions. Now what I'm seeing is that that's not the case. Every time I extrude, I'm getting something different. So I was just looking it up on the screen here, but I was somewhere in the 106 to 107 steps per millimeter mark, which is kind of high. So I should never really be under extruding here. So as you can see right here, I am about 2 to 3 millimeters short, because my mark is right there. Okay, let's do the same thing on the other side. So this one ended, this time at least, about in the same spot. I have 2 or 3 millimeters shy. So what I want to see is, can I reproduce that? If I run this again, does it stop on both of them just 2 or 3 millimeters shy? So I'm going to remark it one more time and rerun the test. So as you can see, this time I am at almost 5 millimeters off, which is, you know, over the course of a print, that's a lot of filament, and you're definitely not getting consistent extrusion. So difference of, I don't know, it's looking like probably about 3 millimeters from the last extrusion to this one. Let's go ahead and do the same thing on extruder 1. So this one seems to have done pretty well this time. Second extrusion, really close to the 3 or 4 millimeter mark this time, so that one seems to have done a lot better than what I have seen before. Again, we're seeing the same problem here. There's one last thing I want to do, and I'm going to actually do a clip on these and not go through my filament runout sensor, because they could be creating quite a bit of drag, particularly the one on the pink one seems to really drag when I pull through it, like pretty rough. And that could be creating some of the problems. So I'm going to clip both of these, do the same test, and I'll just cut you back in here as I run those tests. Okay, so now there are no filament sensors connected, and I wanted to show you the new results. So on the blue one, strangely enough, we are further out this time. So we are almost at the 6 millimeter mark, which is the furthest we've seen in these tests that I've done on camera. And strangely enough, on the pink one, we've actually over extruded this time. No changes in the settings, just took off the filament sensor. This is what I've been seeing the whole time, is we're not getting consistent extrusions out of this machine. So what I want to do, since it over extruded, let's find out how much it over extruded. I will mark the top of that filament here, push on my release, and you can see right there that it over extruded probably about 2 millimeters-ish. So going from an under extrusion of 3 millimeters plus to an over extrusion of 2 millimeters, and whether it is the filament runout sensor or whether it's just the extruders themselves, we're definitely having a problem. So what are my final thoughts on this particular issue? Well, number one, it's important to note that I have spent days working on this issue. It began with me noticing the failure on this benchy, while this benchy turned out just fine. That's where all this began, and then I wanted to do calibration on the printer to make sure that it was ready to go, that I didn't have any more issues like this. Then when I went to calibrate it, I realized that both of these extruders were not acting in the same way. And so what I needed was independent control of these extruders' calibration. I realized that my firmware did not have that ability, so I spent the next couple of days making sure that the firmware was 100% up to my standards and that I had full control over what I needed to do. Obviously, this is above and beyond, and I didn't have to take those steps, but it's important that I represent this hardware correctly, as well as the software that the printer comes with. As I showed you here, I've pulled everything apart to try to figure out exactly what's going on, and while I saw some potential issue for slippage in those extruder gears, I really don't think that that's what's happening. It could be, but I really don't have a great answer for what's going on without a lot more debugging. In fact, if I was going to do my next step, it would be replacing the extruder motors themselves to see if I was dealing with substandard stepper motors, which could be the case. I really don't know at this point. So the severity of this issue, obviously I've shown you, is going to be anywhere from just a few millimeters to up to 10 to 15 millimeters from my testing. I've shown that it's independent of it's unfortunately, from what I'm seeing, at least in my printer, it is inherent to the extruder design or to a part that is included in the extruder, and that's where unfortunately I'm going to have to leave this one. So after the breakdown of the extruder and trying several different attempts to get these calibrated, I've decided to call it quits for now until the root cause of this issue can be found and I can actually calibrate these extruders correctly, because obviously if I cannot count on my extruder to always extrude the right amount of filament for the print and for the space, then I cannot ever count on the quality of this printer being consistent. And I'm not going to waste my time and my filament on printing prints that may or may not turn out well. From here, I was planning on doing some taller prints, some bigger prints, maybe a helmet to show really the capabilities and the size of this printer, but I didn't get to that. And so that's where I'm kind of going to leave this one. Again, this printer has a lot of really good features going for it. It has a solid construction. Overall, I think the components are good components, but with whatever's going on with the extruders, I can't ignore some of the other slight failures that this printer has, because you can't have a major failure like that in a printer when that's what it's designed to do. Again, I'm going to reach out and let JGMaker know about what I found. They're going to obviously see this video. Hopefully they'll come back with some solutions. If I feel like I've got the time, I might play with it a little bit more to see if I can find out the root cause of my issues. I obviously would love for other YouTubers to go take a look at their printers, see if they can reproduce what I've seen, because I don't know of anything else I can do on my end with just one sample to demonstrate whether this is a problem or not for everyone. But if other YouTubers can do that, that would be great. Leave comments, make videos, whatever you want to do to let me know whether you're seeing this issue as well. That's it for this video. Unfortunately, the JGMaker did not turn out as well as I had hoped, and I hate giving bad reviews. So if I can work around an issue, I try to do so, but as you can see here, that just wasn't possible. But as always, if you have enjoyed this video, please leave a like. Obviously, if you have any comments or questions about this printer, things I haven't covered, things I haven't answered, or if I've raised more questions than I've answered, leave those questions down in the comments. Let me know what you think about this printer. Let me know, did you already back this printer? Is this going to change your opinion of your backing of this printer? Were you holding out for my video to decide whether you're going to back it? And what are your thoughts now? Give me your thoughts on what I've shown you here on Kickstarter printers in general. If you have it, should I keep reviewing them? Should I do another one? This is my first Kickstarter printer I've reviewed on this channel, so let me know what you think about kind of the breakdown I've been able to do here. As always, I appreciate your support with watching all the way to the end of this video. I obviously at this point don't know how long it's going to be, but I don't think this was a short one, so I appreciate everyone watching. If you want to support this channel, I've got my PayPal and my Patreon links down in the description below, and that helps the channel grow. That's how I continue to buy stuff for the channel, improve it, lights, camera, action, all that good stuff. Oh, and if you noticed, I've got a new shirt here. This is my design. This is a channel t-shirt. It's my first channel t-shirt, and I shopped around a little bit to get the best quality that I could. I hope you like what you're seeing. If you're interested in this t-shirt, this is available on Amazon. You can pick this up really easily while you're loading up on some of those other goodies. So if you like this t-shirt, there's definitely going to be a link down below to where you can pick up your own t-shirt on Amazon. Currently, only the t-shirts are available. There's multiple colors available. You can get these in normal cut t-shirts, women cut, and youth t-shirts. So you can buy them for the whole family. So this is, again, another way you can support the channel and just show your love. If you pick one up, please send me a message on social media, a picture of you wearing it or whoever you bought it for. Again, thanks everybody for watching this channel. This is the best thing you could have done for me, is just making it all the way to the end here. And I really appreciate it. And if you didn't already know, my name is Chris, and this has been Kersey Fabrications. Thanks for watching.